Last time we unboxed, assembled, and introduced the Sovol SV08 Max. Today it's trial by fire. No, not literally, but with the first test sprints. And let me tell you, this beta unit threw some serious curveballs, from needing crazy high temps to a clipper crash mid-helmet. Let's see what broke, what worked, and how we fixed it. And speaking of what really worked, there's one upgrade on this Max that, even with all these beta quirks, has quickly become our absolute favorite over the original SV08. I'll tell you exactly what it is before we wrap up, but see if you can guess it as we go. To anyone new here, welcome, I'm Gergo, and you're watching Gergo Print 3D, our YouTube channel all about our family-oriented adventures with 3D printing and laser cutting, mostly with my little nephew, Levi. Just like our previous 100 videos, this one also has curated, translation-ready subtitles and detailed chapter markers to make you feel all at home. You might need nerves of steel to survive all the drama in this video. Again, let me preface everything. This is a beta unit, so production machines can and likely will be very different. We will go from the most basic test prints to large functional and decorative items. Since we don't have an enclosure yet, higher temp materials are off the table for now, so we are sticking to PLA and PETG. And without the upcoming filament feeding upgrade, flexible filaments like TPU are also on hold for the time being. But even with these limitations, we will be destroying a hot end, accidentally scraping the bed, throwing out a good number of failed parts, and making plenty of software and hardware adjustments along the way. Are you ready? Let's get into it. And speaking of getting into the action, Sovol is launching pre-orders for the SV08 Max today through the Kickbooster platform. This means you have a chance to snag it at an incredible early bird or even super early bird price. If you're intrigued by this potential, even with the beta adventures we're about to dive into, using our Kickbooster links in the description to pre-order is a fantastic way to support Gergo Print 3D at no extra cost to you. Remember, all this testing is precisely to ensure the final production model is as polished as possible for everyone. Now let's kick things off with the first and perhaps most infamous test print, the 3D Banshee. Yeah, I'm sure you're not impressed by this one. The G-code for an 11-minute 3D Banshee was right there on the included USB drive, but straight out of the box, it just didn't print correctly. There was a severe under-extrusion problem, so bad in fact that the model snapped in half before it even finished printing. Definitely not the print that is going to sell the Max. Something was clearly wrong. After checking the extruder tension, which seemed to be set correctly, I tried printing the same G-code again, but this time I started bumping up the nozzle temperature. From the original and very normal 230°C, I went to 235, then 240, and finally 245 Celsius, where things started to look okay. For the third attempt, I modified the G-code to use this 245C right from the first layer. My beta testing colleague, 3D Print Demon, ran into the same puzzling issue with his hot end. It seems to demand much higher temperatures than usual, especially for filaments like PLA that need a lot of cooling. Beyond the lower thermal conductivity of hardened steel nozzles, our working theory is that the part cooling fans on these beta units might be aimed a bit too high, causing too much air to hit the nozzle's melt zone. Other factors could be at play, but as you see with the other test prints, simply cranking up the print temperatures became a recurring theme. If you're worried that this temperature difference will eat into the printer's maximum 350°C capability for high temp filaments, I suspect those will be less affected because they generally need less part cooling, which should reduce any of these side effects. As I mentioned in my previous video, have you watched it already? I did have to transplant the rear part cooler from my SV08 because this particular beta unit arrived without one. When 3D Print Demon analyzed the original cooler on his machine, he noticed it was positioned 10mm lower on the max. So in my mind, the fix for this cooling issue might be as simple as a slight redesign of the front part cooler, aiming it 10mm lower as well. 3D Print Demon actually measured the nozzle temp and found it was consistently lower than the set temperature, but he'll likely share more details in his own videos and reviews. I'd love to hear your thoughts on this too. Let me know in the comments below. What's surprising is that the tool head on the Max is identical to the one on the Sovol Zero, which had no trouble printing PLA and PETG at their usual temperatures. The Zero doesn't even need a rear part cooler on its tool head, thanks to that powerful curtain fan at the back. So I'm not entirely sure what, if anything, will need to be changed on the Max. As you'll see shortly, due to a nasty clog and a bit of my own clumsiness, I also had to swap in the complete hot end from my Zero. Even though that hot end has a brass nozzle with higher thermal conductivity, the need for higher temperature persisted. This tells us it's likely not a faulty heating element or thermistor, as those were also brought over from the Zero. And spoiler alert, swapping the hot end will have other consequences, so stick around for that. Now, 3 other important points to consider. First, testers of the production units haven't mentioned needing higher nozzle temperatures. Also, I haven't yet received the upgrade package Sovol is sending to bring our beta units up to par with the production models. So the jury is still out on whether this will be an issue in the final version. Second, this whole temperature thing might be a non-issue for many of you, especially if you're planning to replace the toolhead anyway. The upgraded CAN bus toolhead data cable opens up a world of possibilities for Voron-compatible toolhead designs, not to mention the Bondtech Index tool changer that many seem to be eyeing as a potential upgrade. And finally, even if nothing changes with the cooling and higher nozzle temps are needed, there don't seem to be any negative side effects from just increasing these temperatures. Looking at that third 3D Benchy, it actually turned out pretty good for an 11-minute print. The layer height is 0.25 millimeters. Cooling seems pretty good, even though at this point I hadn't even realized my rear cooler was missing. I imagine it would be even better if that cooler was installed and working. What I really want to draw your attention to is how smooth this Benchy is. After a proper input shaper calibration, it's free of any ringing, and what's particularly interesting, no VFA or vertical fine artifacts either. You like how that turned out, right? If so, how about liking this video too? It helps us out a ton. You will see why this VFA point is worth mentioning as we get to other prints. After the initial Benchy success, I unfortunately wasted a good chunk of time trying to replace the missing rear part cooling fan. I didn't have the necessary 3010 fan on hand, so I thought, why not try to redesign the fan shroud Sovol published on the SV08 GitHub repo. My plan was to simply lower it by that 10mm and resize it to fit a 4010 blower fan that I did have. Well, that bright idea did not only turn out to be a total dead end, but it also ended up scraping my beautiful PEI sheet. Though, as you'll see, this wasn't entirely my fault. You see, the big problem with trying to shoehorn in that larger fan was that it interfered with the printer's homing sequence. And if the printer doesn't home correctly, it then tries to perform its nozzle cleaning procedure in the wrong spot. Now, that wouldn't normally be a huge disaster if the nozzle cleaning plate wasn't positioned a full millimeter below the build surface. So this nasty scraped line you're seeing here, that's exactly where the printer thought the nozzle cleaner was. Ouch. This is, frankly, a potentially ugly design flaw. Any homing issue really shouldn't result in damage to this gorgeous and, believe me, hard-to-come-by PEI spring steel sheet. Thankfully, 3D Print Demon cooked up a perfect and super easy solution. It's so simple that production units might even ship with this modification. But if not, you should definitely consider doing it yourself. Just raise the nozzle cleaner by about 1 millimeter by adding a washer or two underneath it. Then you will need to modify the nozzle cleaning macro in Clipper to perform the cleaning routines 1 millimeter higher, safely above the build surface. After that rather pricey detour, a cost kindly covered by Sovol as they are sending a new PEI sheet, thank you Sovol, I borrowed the rear part cooler from my regular SV08. I then printed an upgraded bracket for it, designed to sit 10 mm lower using ASA on my 3D Tech Q1 Pro with its heated chamber ideal for printing high-temp filaments. With that upgraded cooling finally in place, I set out to print this tall height test. I had to stop this print at 459 mm because the y-axis drag chain started interfering with the filament path. But don't worry, this is just another quirk of this beta unit with its temporary filament feeding setup. We'll soon be getting the updated feeding system where the filament enters about 50 mm higher, so there'll be no danger of it crashing into the gantry. Once again, I really want to highlight the excellent surface quality of this tall test object. It stands in pretty stark contrast to what some of the next prints will show us. Before we dive into those other prints, we just had to print something that truly takes advantage of this awesome, massive print surface. So I took our favorite low poly Black Panther model by nbarb01 and scaled it up to a whopping 600 mm in length. That's about the biggest you can fit diagonally on this bed. And just look at that first layer. Z offset calibration and automatic bed leveling are working flawlessly here. Could this be our favorite feature of this printer? This print involved a lot of tree supports, which also served as a great test of the printer's mechanics and overall reliability. I didn't try to rush this one. I printed it using Sovol PLA with the default print speeds from the stock Orca Slicer profiles, running at about 21 cubic millimeter per second volumetric flow. The only change I made was bumping that nozzle temperature up to 245 C, consistent with our earlier findings. We used 3 walls and lightning infill, except for the section where the tail meets the body. For that critical area, we added 15% 3D honeycomb infill using a spherical modifier in the slicer for extra strength. One thing to note, the stock presets consistently seem to underestimate printing times. This one was estimated at around 19 hours, but ended up taking a full 21. Still, I'm really happy with how it turned out. The supports came off relatively cleanly, and the large flat areas are impressively smooth and artifact-free. All right, next up, let's try something with the beautiful silk filament Sovol sent us with the machine, starting with this articulated Fox model by Saber 3D. An articulated model like this is great for testing flow rates and print clearances, though at 200% magnification, those clearances shouldn't really be an issue. It printed beautifully. However, here's an interesting observation. The exact same G-code, when printed later with a brass nozzle, resulted in a much shinier finish from the lovely 3-color filament. This is likely due to the better heat transfer of brass. And we'll see this difference again with the helmet prints. This massive build surface isn't just for giant single prints though. It's also incredible for batch printing. For example, I recently printed a whole army of these articulating lizards to take to a market at an upcoming children's summer camp. On this SV08 Max, I was able to print 31 of them in a single go. To put that into perspective, my original SV08 with the 350 by 350 bed, like the Creality K2 Plus, could manage about 15 of these, half as many. And a very common 256 by 256 printer, it would top out at just 6 lizards per batch. So this huge bed is a massive time saver and lets you really maximize unattended printing. This could also be incredibly handy when doing multicolor prints later on, helping to optimize purge waste when you're printing many parts. Being able to reliably use this entire massive surface for batch printing like this is a huge plus. Is it the biggest plus? Possibly one of the contenders for our favorite upgrade. We'll see. Alright, time to go large. But big prints bring big troubles. I sliced this popular Mandalorian helmet model by the Broken Nerd 83. The designer's name kind of foreshadowing the experience, perhaps, from Thingiverse, aiming for a 16-hour print. But I had to restart it pretty quickly after the first attempt. If you look closely, only 2 tiny points of this model actually touch the build plate. The rest is propped up on these snug supports. And impressively, no supports at all for the dome inside. Critically, during that first run, one of these tiny contact points just didn't stick well. So I cancelled it, paid extra close attention to cleaning the PEI surface with my trusty 99% isopropyl alcohol, and the second attempt was off to a much better start. Now, I have a few other relatively expensive machines to compare this to, and yes, the surface quality could be better, but for a printer of this size and speed, it's certainly passable. I'm not seeing any obvious banding or VFA on the smooth vertical areas, except of course on the snug supports in the center opening, where print quality isn't really a priority. The 3-color filament did twist a few times along the very long path from the spool to the extruder, which is what's causing those interesting color changes you see. And no matter what we tried in Orca Slicer, we could not get rid of those 2 stupid skinny supports which quickly collapsed anyway. It led to some rogue extrusion near the 2 earpieces, but thankfully that debris is fairly easy to scrape off at the end. Some of you might have pointed out this top panel. It's actually just a piece of an old election poster. I've built a whole enclosure out of that stuff before. You can watch that video if you're interested. Its main purpose here is to offer some temporary dust protection for the exposed linear rails. Not super effective, but better than nothing. And it's also a handy spot to store light things on the top of the printer. The other temporary additions are these 2 clamps I'm using to secure the printer to this 700 by 700 millimeter table, which is barely big enough for this machine. I know it's not ideal from a resonance dampening perspective. It's just another temporary fix until I can design and print some TPU feet to stop this beast from trying to jump off this IKEA coffee table. Things were progressing, but then one side of the central supports collapsed and scraped against the tool head. Luckily, just bending and snipping the curled up piece avoided any further trouble, and the support even managed to recover later on. But soon after that, the whole print had to recover from something much scarier. I was still awake, working in my office next door, when suddenly noticed the absence of the usual printer noise. The fans had stopped. I rushed over to check, and sure enough, Clipper had crashed with a bed heating verification error, stopping the print 11 hours into its 16-hour journey. The bed felt like it was still at temperature though, so I did the classic IT crowd fix. I turned it off and on again, hoping the power loss recovery, or PLR, would, well, recover. And yes, upon powering back on, it prompted me if I wanted to continue calling. An interesting bit of translation there. This beta software has quite a few of these language quirks on the device screen. You can see the bed at this point was just 2 degrees below the target printing temperature. The software recovered beautifully. It resumed keeping the bed at 65°C and then heated the nozzle to 160 C first, which is above PLA's melting point, before moving the tool head away from the spot where it had parked itself and fused to the print. I quickly snipped and later cleaned that contact point with a flat cutter. This preheating to 160 degrees is crucial for PLA, but it might not be enough for higher temp filaments. Hopefully the PLR routine is smart enough to adjust for those, but that's something we don't know yet. And with those higher temp materials, opening an enclosure door to clear a blob could cause warping too, a different kind of disaster. But since we're printing PLA here, the PLR was progressing okay. As you probably noticed during that recovery sequence, the tool head then homed only in the X and Y. The micro switches in the end stops provide much more precise positioning than the sensorless homing on the original SV08, which means significantly less horizontal shifting at the resume point. Now either the software resumed one layer too low, or the motors had sunk a tiny bit despite having dampeners, because there was a lot of scraping and nail biting for me during those first few resumed layers. But that good old first layer bed adhesion proved to be an excellent foundation, and the print survived the disaster with just a faint line, which luckily even fits with the helmet's design. A solid foundation. Could that be the secret to our favorite update on the Max? Keep those guesses coming, and I'll tell you for sure at the end. After all that excitement, I went to bed, really hoping that heater verification issue wouldn't pop up again. I woke up to the satisfying sight of the last few millimeters being laid down on this now close to perfect print. With that unwanted intermission, the 16-hour print eventually took 17 hours to complete. The only real casualty was the time-lapse footage, as only the part after the recovery was rendered. But crucially, this experience has actually reinforced my trust in the SV08 Max's overall reliability and its ability to handle unexpected issues. Nice, right? If you found that recovery as interesting as I did, and you want to see more on these Sovol printers, please be nice to us too and hit that like and subscribe. A huge thank you if you already have. The bed heater itself is well sized. It only needs about 10–30% power to maintain 65 C, so the error wasn't due to an undersized heater. After discussing it with the Sovol team, we slightly adjusted the verify heater settings in Clipper to give it just a bit more leeway while still keeping everything safe. These new settings have been tested with more day-long prints, some at even higher bed temperatures, and they've all been free of this particular problem, though not entirely free from others, as you're about to see. True disaster struck while printing the last few parts of this Mando helmet, the earpieces. The first batch printed mostly fine, with just one piece detaching and failing. Clipper's extrude object feature did its job perfectly, and I just continued printing the rest. It was while reprinting that one last missing piece that an innocent mistake, or perhaps not even a mistake, more like a perfect storm, occurred. The filament ran out, but its very end got snagged at the entrance of the runout sensor and didn't actually trip the detector. This set off a chain reaction of problems that eventually led to the complete destruction of my hot end. Yeah, that was all on me, by the way, but still. It's worth noting that this whole issue likely wouldn't have happened on the final production unit. Sovol is replacing this simple runout sensor with a more advanced filament movement detection and advancement system. But back to the tragedy. Without proper tangle or runout detection, the strong extruder just kept pulling and grinding away the other end of the trapped filament. Eventually, this completely clogged up the hot end. I took it apart to investigate, but the stem of the nozzle had somehow fused itself to the copper lining of the heatsink in the cold zone. When I tried to remove the piece of filament, the nozzle stem got pulled right out of the heatsink with it. The real problem arose when I tried to reinsert that nozzle stem back into the heatsink. I'm still not entirely sure how this is supposed to be done properly. No matter how I heated or cooled the two parts, hoping thermal expansion would work its magic, it just got stuck halfway in. I couldn't push it further in, couldn't pull it out. Eventually, I resorted to cutting it off with my new Dremel and drilling out the copper lining. By that point, the whole thing was completely ruined. All further testing of the SV08 Max screeched to a halt. But only for a moment. Then I had a brainwave. My Sovol Zero has a matching hot end. So after demolishing my SV08 for its rear cooler, I now had to temporarily retire my Zero as well, at least until the replacement hot end arrives from Sovol. Now, this replacement hot end from the Zero came with a brass nozzle, which I didn't swap out for the original hardened steel one. This gives us an interesting chance to compare print results between the different nozzle materials, though both are still 0.4 millimeter. With the silk filament, we not only got shinier print surface with the brass nozzle, which is kind of expected due to better thermal conductivity leading to a slightly higher effective filament temperature, but also started seeing more pronounced vertical fine artifacts or VFAs. And this is harder to explain as I only moved the hot end itself, keeping the original heaters and even the extruder fan, and of course not touching belt tensions or anything related to the motion system. Notice how much smoother the surface was on that last earpiece printed with the original hot end. We are still digging into the reasons for this, which conveniently brings us to our next print, namely this portable chair model Levi found on Makerware, designed by Yimei Design. For added strength and flexibility, we decided to print this one out of PETG, starting with these smaller accent pieces in green. We only caught the under extrusion with this green PETG well into that first print attempt. It was the same issue we've seen with the stock PLA presets, insufficient filament temperature, even with the brass nozzle. To save filament while we figured things out, we excluded all but one of the green objects from that batch, and then, while that single piece continued to print, we progressively increased the nozzle temperature from the 245 Celsius. Once we reached 260 degrees, the layers on that test piece started to look much better. So for the reprint, we used 260 degrees from the start. We also increased the bed temperature in the slicer preset to a more typical 75 degrees for PETG. The bed heater, with its adjusted clipper settings, handled this perfectly. And our new thermal camera from AliExpress confirmed nice, even heating across the entire build surface. To ensure our PETG was dry, especially since it's more hydrophilic, we utilized our single spool Sunlu filament dryer. After the quick temperature tuning we did with the green PETG, we ran a proper temperature tower for the white PETG we plan to use next. Then, before printing the main event, the black case and seat combo, we also ran a flow rate calibration test. If you need help with all these filament tuning tests, I recommend our earlier video on the topic. That flow rate test finally pointed to the main culprit for the remaining issues. Sovol's default max volumetric speed setting of 21 cubic millimeter per second was just way too high for PETG. Bringing it down to a more reasonable 14 finally fixed the extrusion consistency. The last component, the black case, came out much more evenly extruded. However, we are still not entirely happy with the surface quality. Something definitely changed after replacing that hot end, and the investigation continues. This is a practical little stool The under extruded legs had no problem holding Levi's weight, but later when I tried it, one of the white legs broke. But I reprinted it using the updated flow rates, and now it is much stronger. Of course, that first Mandalorian helmet was way too big for Levi, so we rescanned his head. He has much shorter hair now than last summer when we originally 3D scanned him. If you're interested in our experience with 3D scanning people, you can check out our video on the Creality Ferret Pro. Anyway, reprinting the helmet scaled down for Levi gave us another good opportunity to compare the print results for the two different hot ends. For this second helmet, we used a layer height of 0.25 instead of the 0.2 millimeters we used on the first one. Whoa. And the slightly reduced overall size also helped make the print quicker. This time, thankfully, there were no mishaps during this 15-hour completely successful project. Given the exceptional capabilities this printer has shown, especially for large items, the opportunity to create a full Mandalorian costume has opened up, and we are excited to pursue that. Stay tuned for updates. Before we get to our absolute favorite upgrade on this SV08 Max, let's quickly recap. So there you have it, an unfiltered look at our journey with this beta unit, all in the effort to make the final production model as reliable as possible for everyone. Now, speaking of that production model, pre-orders start today. If you're quick, you might even be able to snag this printer at an incredible early bird price of just $999. Even at its launch price of $1299, we believe its unique capabilities, like the massive build volume we've shown off, make it well worth considering. Sovol is experimenting with a new sales approach using the Kick Booster platform. So if you're interested in pre-ordering, please consider using the updated links in the description of this video. It's a great way to get the printer at the best early bird or super early bird prices, and it also gives our channel a small commission at no extra cost to you, which really helps us keep making these videos. You can expect a follow-up video detailing our experience once we receive the upgrade package from Sovol. I also plan to post about silencing the cooling fans once those parts arrive. And no, we haven't been totally discouraged from trying to install CoPrint on this beast either, so that might still happen too. All right, so after all that, what is it? What's the one feature that has quickly become our favorite single upgrade on this SV08 Max, especially compared to the original SV08? I hope some of you guessed it along the way. For me, without a doubt, it's the new bed. While we personally never had major issues with the original SV08 bed, we know for some of you it could be a real pain point. Well, Sovol has clearly listened. This new high-quality, 8mm thick, super flat and incredibly robust, quick heating bed, combined with the effective auto-leveling, has been an absolute dream for first layer adhesion and consistency, even on these large-scale prints. It just makes using the printer of this scale so much more reliable and enjoyable. So, until next time, make sure to watch our unboxing and assembly video for the SV08 Max right here, or check out more of our 3D printing adventures in this playlist. Either way, be sure to go print 3D. Thank you so much for watching another Gergo Print 3D video all the way to its end. Enjoy and happy printing!